In this Flightstream tutorial, we're going to be going over the TFI Mesher and its capabilities. So the first thing we're going to do is go to the CAD Create window, and we're going to transfer over our curves using the Transfer Curves button in the CAD folder. Due to this model, we're going to need to remove some of the curves that were transferred as they're going to overlap with others. The upper and lower component both share this curve, so we're going to remove one from each, so there's one remaining. Now we can transfer the curves for our wing base, and we have all the curves that we need for our wing now. At this point, we're going to use the CAD Create tools to get the curves from our fuselage. We don't want all of the curves that are defined on the CAD model here, so we're going to do this manually. Now we've got our symmetry plane curve. We're going to get this curve to capture the fuselage shape. And we also want some of the curves to help connect panels to our wing. Like in this case, we're going to connect our two virtual curve nodes together, select the two CAD panels that we want to project to, and then use this tool here with our projection vector in Y and selecting bidirectional projection to generate a curve that connects our wing root to the fuselage node. We're going to do the same for the lower surface as well. Now we're going to connect the lower portion of the blunt trailing edge to one of the curves that we created beforehand to help with our panel creation. Make sure you're selecting the proper CAD panels for projection. We're going to make things a bit easier on ourselves later on by combining some of these curves to make the panels larger. This curve needs some adjustments, so we're going to delete it and recreate it. Now we'll properly combine the curve on the bottom. And do the same for the top. From here, we're going to split our top and bottom curves so that we can create projected curves along the fuselage to make panels that align with the wing mesh and the fuselage mesh individually. Now that they're split, we'll create our curves and project them to the fuselage after we select the proper CAD panels and alter our projection vector. With this done, we should be able to move to our TFI meshing tool now. Here you can see that each of the curves is automatically given a default number of 10 grid points. Following Flightstream best practices, we're going to make our wing have 60 points on the top and bottom in the chordwise direction. As those upper and lower curves along the fuselage are also going to be part of panels that have the 60 points, they need to be adjusted as well. For the TFI Mesher to work properly, opposite facing curves must have the same number of points. So we'll set this set of curves to 25 and then the lower set to 15. Then we're going to move to our forward panel on our fuselage and set each of the curves to 40. Note the clustering schemes are available for each curve. We'll set up our second panel. Increase the clustering rate here. Then we'll move to the rear. Select our 3 curves, as we need them all to have the same number of points. Set up a growth rate again, and then move to the final curve set. Here we notice that this curve isn't properly split, so we're going to delete it and recreate it one more time. In the proper structure for our panel shapes. With that done, we can change the number of points appropriately. This becomes 26 because we need to also deal with the blunt trailing edge on the rear of the wing. This will normally go to 15. We'll finish up the fuselage here, using clustering rates to properly capture our geometry, and then this will become 41 as it's the end point for our panel. Now we're working with our blunt trailing edge. We're going to select each virtual curve that is on the blunt trailing edge and set it to 1 total grid point. Small curves can get a bit finicky, so it takes a little bit of editing here. We want to reset this to 10. And then double check our blunt trailing edge points. Here we can see that the root of the blunt trailing edge is still set to 10, so we'll go back and properly set it to 1. And double check this curve here. With this done, we can move to properly creating our panels. This step is quite easy. First, we're going to create groups so that when we transfer over to our mesh, they'll be split into different components. So we'll use the fuselage, wing, and wing base as our 3 components. We'll select our first curve and start creating our panels. Here we work with a 3-sided panel. Note that the 3-sided panel needs to have the first and third drawing curves meeting at a point, with the second drawing curve acting as the middle portion. Also note that you can select multiple curves per portion of the panel. As you can see with the second set, we have 2 curves that are on that portion of the panel. Make sure to go either clockwise or counterclockwise and do so consistently within each panel. It doesn't matter between different panels if you go clockwise or counterclockwise, but for the mesher to work properly, you need to have it such that the curves are selected in a consistent order. From here, it's quite easy. We'll create our panels and select our proper CAD faces to project to. Right now we're just working with the fuselage, so we'll just keep creating panels, selecting our curves, and then select the fuselage portion of our CAD to project our panel to. Since we've already set up our curves properly with the correct number of points, we don't have to worry about any type of errors that come up. Here, once again, we'll see that we can select multiple curves per side of the panel, specifically the fuselage and the root portion of the blunt trailing edge of the wing. Note that we selected our growth rates with proper blending in mind of the mesh. There will be some banding, but as long as the growth rates are kept within a acceptable amount of each other at the points where the panels blend together, the mesh will have no issues with the solver. And with that, we've set up our fuselage, so we'll take our panels that we've created here and assign them to our fuselage group. And now we will move on to our main wing. When working with the wing, splitting a wing surface into an upper and lower portion will make it easier for the proper panel projections to work. This is part of the best practices as well. It's not strictly necessary, but it is suggested. Project to the upper wing. And our upper wing surface is done, so we'll move to the lower wing surface. Create a new panel. Making sure to select our curves in the correct order. Once again, 1 and 3 should be parallel or opposite of each other on the panel face, not necessarily parallel. Same with 2 and 4. Here we accidentally selected multiple curves, so we'll double click to deselect and then reselect. And that is our lower wing face completed, so now we will move on to our wing base after assigning the panels to the proper group. Here we're selecting our curves for the wing base. And with that, we've created our mesh, so we'll transfer our mesh using this button here. And here we can see the finished mesh. We're going to set our wing base as a base region, as it's a blunt trailing edge, and we're going to hole fill the edge of our wing so that the wingtip has a mesh at the corner. And then we'll automatically select our trailing edges and wake termination nodes using the auto detect features available to us. And then for our body carryover loads, we'll create our relaxed cut-out trailing edge along the lower portion of the fuselage and disable the wake nodes on that portion for numerical stability. And with that, we've used the TFI Mesher to create our mesh, so we'll create our boundary conditions now and set up our simulation for how we want to run. We've already defined our simulation settings for the runtime tab, so we'll initialize our solver. And then from here we can just run the mesh. And that's it. This was a comprehensive walkthrough of how to use the TFI Mesher in Flightstream. This can be used for much more complex geometries with more curves and more panels, but the approach is going to be the same. Please let us know if you have any questions, and thank you for tuning into this tutorial.